The next part of our journey of completing the square is we're going to be looking at the discriminant and the nature of roots. So if we have a quadratic equation in the form of ax squared plus bx plus c, what we can do is we can plug it in to the discriminant b squared minus 4ac. This will inform us how to solve the equation, or the best way. Now keep in mind, there are basically three ways we can solve a quadratic equation: factoring, completing the square, or the quadratic formula. So it tells us how to solve, but it also tells us about the nature of the roots. Now the nature of the roots just is simply how many solutions we have and whether or not those solutions are rational, irrational, or even real. So let us take a look at the discriminant. So if we have an equation in general standard form, ax squared plus bx plus c is equal to 0, we can recognize the discriminant, b squared minus 4ac, because it is the expression that is underneath the square root sign. So that's what the discriminant is, b squared minus 4ac. It would tell us if we should solve it by factoring, completing the square, or quadratic formula. It'll also tell us how many solutions we have, and that is called the nature and the type of solutions. So let us go through and take a look at some quadratic equations. So example, I here have solve. I understand that you can know how to solve, or you have the ability to solve each of these four equations. Pardon me. Each of these four equations, 1, 2, 3, 4, we can solve them, but how? So my argument here is, let's take a look at the discriminant. So what I'm going to do is I'm just going to tell you that the discriminant is going to be b squared minus 4ac. Now I've done that for each of the four equations, so I'm going to calculate the discriminant. And for each equation, our value of our discriminant, which I will highlight in green, is different. So let us look at the first example. The first example, what we're able to see is that the value of the discriminant is going to be 64. Now the solutions are going to be -7 and 1. Now keep in mind, the discriminant is just simply the value underneath the square root. If you notice, we have two solutions, and both of these solutions are what we would call rational. So I just want to remind you what a rational number is. A rational number is any number that can be written in the form of a over b, where a and b are integers, and b is not equal to 0. All of the numbers that I've just circled, 4, 1/2, or 139 over 4, are rational numbers. Some people think of it as any number that you can write as a fraction. Well, let's look at what is an irrational number. An irrational number are just numbers that aren't rational. So, for example, the square root of 2 is an irrational number because you cannot write that as a fraction. Root 6 to root 11. Those are going to be the type of irrational numbers that we are going to be familiar with in this. Pi is also irrational, but I'd be very surprised if we came up with the value or a solution to a quadratic equation that was pi. Now, let's go over the second example here. The value of my discriminant is 24. If you notice, I have two solutions. And, however, these are irrational. If I take a look at the next solution, the value of my discriminant is 0. It appears like I only have one solution, and that one solution is rational. It's 2. Last but not least, the third example. If I calculate the value of my discriminant, the value of my discriminant was minus 27, negative 27, pardon me. The value of my discriminant is negative 27. However, when I solved it, it had no solutions. Now, I'm skipping over an important part here. I'm skipping over the part where we're able to determine what the solutions are. You have experience in doing that. Well, let us focus, let's go all the way back and try to think about, make sense of what's going on. Now, I'm just going to go all the way back to the quadratic equation. Y or x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. What I'm going to do is I'm just going to make a small step and splitting up that as x is equal to negative b over a plus or minus the square root of b squared minus 4ac over 2a. Let's start talking about the number of solutions. Well, I'm just going to highlight my discriminant here. If this number here is 0, then you'll have one solution, because this part of the equation will go towards 0 or will be 0. So you have one solution, that is negative b plus or negative b over 2a. Now, if this number is negative, if your discriminant is negative, well, you can't take the square root of a negative number, so there's going to be no solutions. But if this number is positive, you're going to have two solutions. You're going to have one solution where it's negative b over 2a plus the square root of b squared minus 4ac over 2a. And the other one will be negative b over 2a, subtract that quantity. So that's how you can tell the number of solutions. So I've just identified or created this table. Here we go. See if that makes sense. I'm just going to maybe rewrite my quadratic equation in that very special and weird way. I've covered out how many solutions we have. Now, I'm going to say, now, what if this discriminant was a perfect square? Well, it's a perfect square in two scenarios. It's a perfect square, you'll have a rational solution, because negative b over 2a will be a rational number. And any perfect square you can take the square root of, so the quantity on the left-hand side will also be a rational number. A rational number plus a rational number will always yield a rational number. What is a rational number again? 1/2. 4. Negative 2 over 3. Those are rational numbers. If your discriminant, the quantity underneath the radical sign, is not a perfect square, you'll end up with an irrational solution. This table is kind of important because, let me get rid of all of the garbage that I have put here. It tells us how to solve an equation. Is if your discriminant is negative. you have no solutions. So don't even bother trying to solve it. That's important. If your solution, or if your discriminant is equal to 0. And just recognize that 0 is a perfect square. You have one solution, and the type of solution is rational. As soon as you have rational solutions, you can factor. You can always complete the square on any equation, never fun, or you could always use the quadratic formula. If your discriminant is greater than 0, that is, if it's positive and not a perfect square, well, you're going to have two solutions. And your solutions are going to be irrational. If you think about all of the equations that you've factored, you never had solutions that were irrational numbers and you factored it. So if you know your solutions are irrational, do not factor it. It's not possible. However, if you have a discriminant that is positive and a perfect square, now perfect square yields to factoring, or you could ultimately complete the square or the quadratic formula. My order of preference when solving an equation is I choose to factor if I can. Sometimes that's not possible. Well then, me personally, I like to complete the square. Most people don't. A lot of people just love to use the quadratic formula too. So that's the value of the discriminant. It tells you what type of solutions, how to proceed, really fundamentally important.